To follow up what we did yesterday with graphing radical equations, we're now going to get into solving radical equations. We're going to jump right in here with a real basic example and use some previous knowledge to come up with a common sense way to solve this problem. Previously, in this course and in other courses, you've solved equations such as this, x squared equals 25, by taking the square root. And that allows us to get rid of the square because a square root and a square are opposites. So therefore, it should follow that if I have a square root equal to a number, I can go the other way. I can square both sides, and the square will cancel out the square root. And we get a nice equation like this. 3x minus 2 equals 25. Add 2. 3x equals 27, so x is 9. There's your basic algebra, just getting rid of a radical by squaring both sides. That hopefully makes sense to all of you. Now it is important when we do these that you check your answers, and we'll see why in a minute. So if we plug 9 in for x, 3 times 9 is 27, minus 2 is 25, the square root of 25 is 5, so that does work. And you'll see why we're going to do that in a moment. Our second example here is going to be a radical on both sides type problem where we are looking at what's going to happen with an extraneous solution. You've seen that term before when we looked at rationals. And the thing was with rationals, we said an extraneous solution occurs when the solution would make the bottom be 0. Well, that never really worked out very often in our worksheets. You're going to see here when we do these, the extraneous solution is going to occur quite a bit. So, a radical equal to radical situation is very nice to solve, because to solve it, all we're going to do is square both sides. Well, because they're both radicals, that leaves a nice simple situation where both radicals cancel out, and you have a simple linear equation. We minus x from both sides. Negative 2 equals x minus 3. Add 3, x equals 1. And at this point, everyone's pretty happy. This is pretty easy math. Here's where we run into a problem, though. We always have to check our answer. When I plug 1 in here for this x, 1 minus 2 is negative 1. So we end up with the square root of negative 1. As we all know, that's going to lead to an imaginary solution or a complex solution. And for the sake of our solving here today, we're going to call that solution extraneous. So this answer has no real solution. Or the empty set, as we've used before, for our no real solution. The solution is in the set of complex or imaginary numbers, so therefore we're going to call that no solution when we work with this, because that's why we want to get in that habit of plugging back in and checking our answer. You want to make sure you don't create a situation that can't happen from your solution. Our next example here is going to push our memories a little bit, as we're going to get into what happens when you have a binomial on one side, and it's going to lead into a quadratic example. So just like before, I get the radical by itself and square both sides. N minus 6 squared equals 30 minus 5n. Now, this is a good opportunity to review the stuff we've been talking about with rationals, how we cannot call this n squared plus 36. Do not do that. Someone will. Don't be that someone. N minus 6 squared means n minus 6 times n minus 6, which is n squared minus 12n plus 36 equals 30 minus 5n. So now, by squaring both sides, we've created a quadratic equation. To solve that, we set it equal to 0, n squared. I'm going to add 5n to both sides. Minus 30. And now we have a quadratic situation that's factorable. N minus 6, n minus 1. So the two solutions we would get from that are n equals 6, n equals 1. As always, we need to check for extraneous solutions. We go all the way back up here. So we go back up to the original, and we want to check our solutions. Our solutions were 1 and 6. If you plug 1 in here, 30 minus 5 times 1 is going to get 25. And so if we plug in 1 here, 1 minus 6 is negative 5. So we get negative 5 equals the square root of 25. Well, that's not true. The square root of 25 is 5. 5 does not equal negative 5. So therefore, 1 is an extraneous solution. So we have to eliminate that from our solution set, and we check 6. 6 minus 6 is 0. 5 times 6 is 30. 30 minus 30 is 0. 0 does equal 0. So therefore, the only solution that works is 6. So when we present our solution, we have one extraneous, one real solution. We only use the one real solution. So you'll be presented with some of these problems in a little bit of a different manner. You'll have to kind of use some of your algebra solving skills here to use what we've done today and apply it to the worksheet you're going to get tomorrow. But also, you're going to come across one problem that's going to be something of a bear, and I hope all of you will give it a shot, and we'll see how we do.